Hello everyone. I'm sure your preparation for NEET must be going on pretty well, right? Nice to see you all again. I'm the Assistant Dean and the Head of Department for Chemistry for VMC Medical, right? And this short video is going to be on a discussion on this chapter called periodicity, right? Periodic classification of elements. So the discussion is going to be short and crisp on what we have seen from this chapter in the past 10 years of NEET exams, right? And what exactly we should be doing in terms of preparation for the coming NEET, right? So I'll just screen share for a moment. Just give me a moment. Great. If you can look at this fact sheet, right? This fact sheet shows that in 2013, from where I started this analysis, there was no question from periodicity. 2014, we suddenly saw 3 questions coming from this area. 2015, there were roughly 2 questions from this area. So a lot of questions from periodicity also have a link with P block elements, right? So the questions are kind of gray. They can fall under P block, they can fall under periodicity, but I picked up questions which are very typically from periodic classification. In the repeat paper, we had only 1 question. 2016, there was 1. 2017, again, there was no question. 2018, there were again 2 questions. 2019, there were 2. 2020, there was just 1. And 2021, there were 2. So if you kind of average out, I can see just 1 or 2 questions coming from this chapter. So let's take this year by year, right, just to see what all has come so far. In 2013, there was no question. So we can just omit that. 2014, we suddenly saw 3 questions. Now, if you look at this question is based on simple concept of asking which ion is isoelectronic, which has same number of electrons. Does not very typically fall under the class of periodic properties, but I think this question is something which 100% of the students should be able to do. All you have to do is just calculate the electrons. Now, if you look at the second one, this is on ionic radii. So this one is, of course, an easy question to attempt. You know that cations, are smaller in size due to increased effective nuclear charge, and anions are larger. So I don't think this is something which is very unachievable. And the third one, which I've seen, is from lanthanide contraction. Now, lanthanide contraction can also fall under D block. So this might be a little of a gray question, but because it's a question which talks more about screening effect, decreased screening, and screening effect is a topic which we see under periodicity. So I've classified it here. Easy question on lanthanide contraction if you know what it is. 2015, we have seen same number of electrons, isoelectronic kind of once again. So, and then the radii. So my pinpoint is ionic radius as of now and isoelectronic nature of ions. I can once again see 1 question on lanthanide contraction, right? The zirconium and hafnium, this 40 and 72, they have similar radii. So the focus is lanthanide contraction radius, right? Now we suddenly have 1 question coming up from the electron affinity area, right? The process of formation of O2 minus ions in the gas phase and in the normal phase. So this question has got some link with some size of the ion and the repulsions that the incoming electron experiences, right, in terms of its sizes, right? So if you look at this question on the whole, it's more on electron gain enthalpy of the ion and 1 new area, right, which we are introducing now. Once again, I come here, I see some question which is generally on all properties, right? Metallic radius, ionic size, ionization enthalpy, electron gain enthalpy. So this is kind of touching all the aspects of the chapter. So although it's a very short chapter, so I don't think that should be much of a problem. Then we see 2017, we see no question. In 2018, we see which of these oxides is most acidic. So acidic basic nature of oxides could be a part of P block as well. It could be a part of S block, in this particular case. Atomic radius of group 13 elements could be a part of, P block, but because it's atomic radius, so we've kind of put it here. 2019, I see a question coming on detailed ionization enthalpy of second period elements. So ionization energy is now going to be 1 more area. And then amphoteric nature of hydroxide, which again is little gray. One question which in 2020 was totally on IUPAC nomenclature of the new elements, right, which are the latter part in the 6D. Once again, zirconium and hafnium have similar atomic and ionic radii. I have still not seen any question from electronegativity, right, if I can notice this. And once again on isoelectronic pair. So isoelectronic nature, lanthanide contraction. This is a rather short and easy chapter to cover. I have seen questions from atomic radius, some diagonal relations, lanthanide contraction, which could also be a part of F block. Ionization and enthalpy, probably one question on from electron affinity. But there has been no question, particularly from electronegativity, periodic developments, early developments like Doberener's or Newland's laws or Lothamier's curve or modern periodic laws or Mendeleev's periodic law. Even Mendeleev's table, there has been no question. It's more like 9-10 standard area. So although there have been NEET papers where there was not even a single question, right, from this chapter, there is an average of one question per NEET paper on an average from this chapter, which can clearly suggest that some questions from this chapter could also be questions from inorganic chemistry such as P or D block. The link is very understandable. So that will actually make this chapter even less significant, right? So overall chapter ranking, I'll regard this as an important chapter. Not very important, because once you are doing P block, right, so you will be covering some lanthanide contraction out there, or screening effect you might be covering out there. Some nature of oxides and hydroxides, their acidic, basic or amphoteric nature, you will be covering in P block also. So maybe that does not require a very detailed impetus in periodicity. And in periodic properties, particularly, we have seen questions, particularly from atomic radius, ionic radius, the radius aspect. A couple of questions in the past 10 years from ionization, enthalpy, and electron affinity, right? And nothing on electronegativity, particularly, right? We haven't seen any density trends that they have asked us, right? No melting point trends per se, right? Or boiling point trends, nothing like that. So I think pretty harmless kind of chapter, because it's very short, and I won't say it's achievable. And again, this is one chapter which is coming from much younger classes, right? This kind of starts from 8th or 9th standard onwards, you start getting hints of how the periodic table is designed. So believe me, small length of the chapter and easy to capture chapter. It's not something which is incomprehensible. So a small effort can fetch us one or two correct answers to questions. So that is pretty worthwhile. So on a personal note, I don't think you should be leaving this chapter, right? I wouldn't say that you leave this chapter, or it's one of the less important chapters. But if you ask me, I think this is something which you can easily do. And if you can do, then there's nothing like it. If you can even get one question correct from this chapter particularly, I think, you are in a profit situation, right? So wish you all the best for your NEET. Hope your preparation is going on well, and keep revising, right? And keep reading properly, right? And no need to access too much material, right? Whatever you are doing, just keep repeating it and revising it, short tip for NEET. And don't try to do too much in less time, but don't keep wasting your time over just one chapter as well. So there needs to be a balance as far as your preparation is concerned, right? With them on there, I wish you all of you, a very happy forthcoming NEET, right? And happy preparation as well, right? Thank you very much. I'll see you again. All right. Thanks very much.